record on this. Hi, good morning, good evening. Thank you for joining the session. So let me check whether we are recording it or not. Yeah, we are recording it. Thank you for joining session. So in this session, I'm going to cover Python execution model. Okay, what is meant by execution model means how a Python program gets executed. So it is very important for us to understand various terminologies used here. Okay, few people call it as a scripts. Okay, few people call it as a module. Okay, few people call libraries. So we have to understand these jargons. Okay, what is the difference between a module and what is the difference between a Python script? Okay, what are libraries and so what are libraries and etc. We are going to cover the execution model. Then we are going to cover functions, very essential part of the Python programming language. You need to understand functions. Okay, how do you create a function? Okay, and how a function returns a value from it, arguments, keyword arguments, positional arguments, and anonymous functions. And lambdas. So functions play very critical in any programming language. It can be a Java or it can be a Python. So if you have a very reasonably good understanding on functions, that makes your life very easy. So majority of the libraries were written in terms of functions, then object orientedness in Python. So if you have a task, you can break the task in set of functions and try to achieve that task. Or other way to look at it, if you have some task, you can understand the objects and their interaction model across them and try to solve it in an object-oriented programming language. So in Python, majority of the libraries were written in a function-oriented programming language. Okay, so that's the reason having a good understanding on functions will help you to understand the libraries very well. So in this session, I'm going to cover how do you create a function, what is a function, how do you create a function, how a function returns value, arguments and stuff. Okay, that's once we covered functions, then we need to understand exceptions. Okay, this is a beautiful part in Python. So what is an exception? Okay, how do you catch exception? Okay, how do you catch exception? And something like try, except and pass. Those are some um, those are some predefined there are predefined keywords which you need to understand. Try, accept and pass. So I'm going to cover exceptions also in this class. Okay, so this is roughly in this session we are going to cover execution model, functions and exceptions. Hope that is clear, right? So without wasting time, let us jump into the Python execution model. So we'll start with Python execution model. What is execution model? It says how a Python program gets executed. So I'll show you a simple example. Like here I have a Python program. You can see that I have examples in my GitHub repository. Okay, so a simple way to understand Python program is Python program executes from top to bottom. When you write something in this program, when you try to execute, so it runs from top to bottom. Hi CK, are you able to hear me? Hello? Okay. So are you able to see my screen? Or let me text you. Uh, sure, try to acknowledge if you are able to see and if you are able to hear me. Yeah. So now I'm discussing about how a Python program get executed. So it gets executed from top to bottom. That's all we know. So, but there is something uh, when you are, what is the difference between script and module in Python? So what is the variable special, or what is the predefined variable underscore main? So if you understand this sorry, not main, underscore name, this is something tricky to understand. If you understand this well, then you will understand how a Python program is invoked. So how a Python script is invoked means how it is called. So essentially, a Python program ends with .py, right? So I'll I'll show you with one simple example. Uh, Let me write. So I have a Python program and I say hello. Nothing but I'm trying to say hello. So what are the various ways to invoke this? Let me show you. Okay. Python crash course beginners 04 execution model. So so the simple way to execute this program is demo, and I have a 03 Python. So this is how you can execute. You are running this Python module, okay, .py. What we are running this Python module as a script. I think noise around 1 second. Okay. So if you can simply say Python 03, I'm running this Python script. I'm invoking this Python script. So this is running as a script. But if I say something like that, I'm going to REPL and I say import 03 underscore demo. I think I shouldn't have the variable name. Let me do one simple change here to my Python script. So factor rename, I'll call it as a demo. Import demo. So while you are importing the module, the code inside the module also get executed. So what is module? Module is nothing but module in Python is just a Python file. So when you are importing so what do you mean by import? Okay, import means you use the function in that module. So if you say I'm just importing demo, then if I run once again import demo, the print statement in this module is not going to get executed. So essentially what we are trying to understand here is whether a script, you have a Python file, whether it is invoked as a script or as a module, you try to understand. So the demo what I'm trying to show you is, okay, why this is important is when you are writing a modules, then you have to know whether someone is calling it as a script your module or whether it is imported as a module. So that's the essential difference you need to know. Why? Because when you write a libraries, someone will import the functions in libraries and try to use them. Someone will try to execute your library or module to test that the sanity of your library. So what I mean by that is you have some test cases in your module. If someone wants to run it, okay, they can invoke it as a script. So the variable underscore name will help you to understand the invocation type. So whether we are invoking it as a module or as a script. So if I show you little bit change here, I have a variable underscore name. Okay. So let me quit. Now I am running it as a script, Python demo.py. It says main, but now let me import this as a module. Python import demo. You can see this as demo. Okay, not as main. So when you, the variable underscore name will help you to identify how your module is executed, whether it is imported or whether it is getting executed. Why do we need to know that? The reason is, okay, when you have test cases, you can have them in your module itself. So that's little bit about Python execution model. So what you understand is the Python program executes from top to bottom. There are two ways to import a Python program. One is as a module and one is as a script. So how do you identify between script and a module is using this flag underscore name. I know this is slightly tough concept to understand. If you guys have any questions, you can ask me. You can revisit the variable, predefined variable underscore name and try to read about it, okay? So if you're not able to understand, I'll cover in the next session. So I don't want to deal this dry concept further. I'm going to revisit the execution module when we finish, when I touch the Python interview session, okay, which I'm going to touch, because several interview questions are modeled upon this Python execution model. Okay, so without wasting time, let us try to understand the other topic, functions in Python. Okay, so let us try to, what is a function? It's nothing but labeling a block. If you have a block of a code, you label them and you repeatedly use them. You repeatedly use that code. So that's why it's a function. It's nothing but a labeling a block. So I'll show you with one example. Okay. So now for example, I have a function hello world in Python. You need
Hello.
to use, yes.
Yeah. Hi, Balaji. I can't see your screen actually.
You're not able to see my screen.
No, I can't.
Okay, thank you. So I think I stopped sharing my screen or something like that.
Yeah, I can see you talking, but I can't see your laptop screen.
I'm sure. Thank you.
Yeah,
Let me figure it out what has happened.
yeah.
Are you able to see now?
Yes, now I can see.
Thank you.
Okay,
Okay, thank you for notifying me. Okay,
okay.
so yeah, now I now what we are going to see is how to create a function, understand uh, various various pu- various things in functions like how to pass variables, return types, and stuff. So the simple way is like if you want to create function in Python, you just set def, and you need to have a function name and an arguments like closing, opening, and closing parenthesis and a colon. And now you can have anything like I have a print statement hello world. So this is how I created a function. And if you want to invoke function, very simple, you just call its name, function name with its parameters. Currently, we don't have any parameters. So this is how you can invoke a function. So I wrote a function which doesn't do anything great, which just prints hello world. Okay, this function doesn't take any input and doesn't return any input, so any output. So it's not returning, it's not taking any input. So essentially what it is doing is it is trying to print hello world. Now what we will do is we'll now learn about arguments. So inputs to or functional function arguments. So let us pass arguments to function. So the simple way to do passing an argument to function is, now let me change this function to an addition. Def add a comma b, and I'm just printing an addition. I'm just print the sum of these two variables. So here a and b are the functional arguments, a comma b, or parameters you can say, and I'm passing those to function. So add 10 comma 20. Okay, so if I try to do that, it's perfectly fine, 10 plus 20. And you know that functions arguments doesn't have strict data type. You can pass anything, like I'm trying to add 10 comma 20 a integer. I'll try to add strings like hello world. So this function is invoked, even it can concatenate hello plus world. So it is doing it can take anything, it can take float. Okay, so for example 10 comma 2 and 2 comma 4. So it can add the floating points also. So now it is like 12.6. So the data type or the argument data types are not strict. You can pass any arguments, and even if you want to do something like that, if I try to pass, one is like integer, another one is like string. Okay, so Python is going to complain you baking that okay, plus operator cannot be applied on strings, integer plus strings when they're trying to do. So it won't convert the int to string or string to integer. So don't bet, so don't think that plus like it works on all the universal data types. Okay, it try to use the same data types. So what we understand from function is like a function take arguments a comma b, and you are passing those arguments 10 comma 20, and it is trying to do a sum. a summation of them and returning it. So let us try to, so this is with function with arguments. Generally this is called a comma b is called positional arguments. Okay, so these are called positional arguments. I will, I'll cover what is positional argument. Means you cannot miss that argument. You have to certainly pass them, like add 10. If I say like this, okay, it says that positional arguments are mandatory. Positional arguments are mandatory. So in Python, there are two types of arguments. First one is mandatory, or we call it as a positional. Second one is non-mandatory, or we call it as a default. They call it as a keyword argument. So if you understand these two things in Python argument types, okay, you will understand everything. So there are two types of arguments in Python. One is positional, which is mandatory. You need to pass value to them when you declare. Another one is keyword arguments, or non-mandatory or default arguments. So what I mean by that is, let me explain. I will make that b as an, if someone doesn't pass any value to b, I'll say that b will be 10. So here b is called keyword argument or default argument. If you don't pass any value to b, the b is taken as 10. So let me do something like that. Now it is saying, see, if I add a 10, it says 10 plus, you are not passing anything to b, it becomes 20. Now if I do something like that, add 10 comma 40, if you pass, then 40 is going to take. So if I run this code, now 10 plus 40 equal to 50. So now you understand the positional argument, right? Or positional arguments and keyword arguments. So now let me slightly explain you more about the keyword arguments and positional arguments. So I have another variable c equal to 20. It is also a keyword argument, and I have a plus b plus c. So now let me don't pass anything. The first one, I'll have it as 0, 0, 10, 20. Now the output of it is 30, right? 0 plus 10 plus 20, 30. Now the benefit of keyword arguments is order doesn't matter. Pay attention to this. Keyword arguments, order doesn't matter. What I mean by that is, I'll explain you. So now I'll say add 0 comma b equal to 30 and c equal to 40. So very rarely this type of syntax is for keyword argument. Okay, I'm saying b should be 30 and c should be 40. If I run, I can say 30 plus 40 70. This is as equivalent as add 0 comma 30 comma 40. Okay, so if you don't say any specific order, okay, it is going to take the default order. Now if you do, okay, it is like 30 70. But if you want to have add 0 c equal to what, I'll say 10, and I ignored, and b equal to 10. So I can change the order. I need not to follow the same order in which it is declared. This is the benefit of keyword arguments. You need not to follow the same order in which it is declared. So now if I run this code, right, it will, you can see like 10 plus 20, 0 plus 10 plus 20 equal to 20. So That's what I'm keyword arguments order doesn't matter because you're explicitly saying what are arguments, and they are by default they are assigned some values. So if I have 0, okay, now c equal to -10, if I do like this, the essentially this will be like the output of this will be 0. You got it, my point? So simple, there are two type of arguments in Python. One is keyword arguments and another one is positional arguments. Positional arguments are mandatory. Positional arguments are mandatory and keyword arguments are non-mandatory. And the keyword arguments can take any order, but positional arguments should take the same order in which they are defined. These should take same order in which they are defined. Okay, so that's about the keyword argument and positional arguments in Python. Now we understand about arguments. Now let us understand about return values from function. How do you return a value from function? So very simple, right? What the way you, if you want to return a value from function, def I'll just add 10, add a comma b, and you can use the keyword return, and which will just do a summation of both and returns it. So if I say print add 10 comma 20, okay, so now if I run, it adds 10 comma 20, and the return statement is going to return the output of this expression, the evaluation of this expression. It returns, so 10 comma 20 is like 30. So the same rules apply. Okay, the return type can be any Python data type. Okay, it doesn't matter, like I can have it as a floats 10.5 and 20.5. It doesn't matter, it works. Okay, so now let me do a little bit of change. I'll change this to division. Okay, so I'll slightly enhance, or I'll show you one more variable pass. Okay, if you don't want to return anything from function, you can just say pass, which doesn't do anything. It just returns, it passes that block. Okay, so pass means doesn't return anything from function. This is one way to do that. Or if you don't want to use pass, you can use just simple return. Okay, so simple return or pass is both are equivalent. It is not doing anything. It is just returning. It is not doing any computation. It is not returning any value. Okay, so why this is helpful is like someone try to do a division by 0. If b equal to 0, then you will say return, else you will say return a by b. Okay, so for example, the output of this function will be like 20 100 by 20 run. It is nothing but 5. Okay, it divide a by 5. But if someone pass 0, okay, you just say that, okay, you will return none. You don't return anything. If you say return, it returns none. So the simple way to handle this is like, if someone is passing 0, you want to gracefully say them that you shouldn't pass 0. If you say result, okay, div 10 comma 0, if result equal to, sorry, it's not string, none is a different type, none is one data type, print division by 0 is not allowed, something like that, if you want to enhance your code to have better exceptions. So if you see now someone is trying to pass by 0, So you say that division by 0 is not allowed. When you say return, if you are not returning anything, the return type is none. So empty return returns none type. Python has a none type, right? That is what a none type. So this is very helpful for you to understand empty returns. So empty returns are quite common in Python. So to do a special checking, okay. So if we said division, it is division by 0, you just return, and it is nothing but a none, and you can simply compare with the none and say it's not allowed. So if you pass this, nothing is going to happen because I didn't have any print here, okay. Or if you slightly enhance this code, you can have else print result. Okay, if you run like this, 10 by 2 is 5.0. So that is about returning a value from a function. So now you understand an empty returns and stuff. Let us go into a very essential part of functions is like anonymous functions. So anonymous functions. This is the place where people get scared about Python language. But if you pay attention to the simple steps, things, you will easily understand it. What is an anonymous function? A function without name. So I don't have any name to that function. That is called an anonymous function. I create a function, but I don't create any name to it, okay? So that is called an anonymous function. Like simple as a def add, I say a comma b, and I'm just saying return a plus b. This is one add function. I can simply convert this into anonymous function with keyword lambda, lambda, a comma b. These are arguments. These two are arguments to function, and I can say a plus b. This is an expression. So this is an anonymous function, nothing. This is an addition function. Addition function without name. So you can create a function without a name. This is like an anonymous function. I don't give any name to this function. Okay. So let me show you a few tricky parts in functions. Then I'll explain you a little bit of anonymous function one more time. So right, in Python, everything is object. So what I mean by that is I'll show you with one example. Let's go back to our favorite add function, add a comma b. Okay, then return a plus b. So now let us say type of add. Okay, so if I run this, sorry, I'll just add print also, you'll understand. So it is saying a function, it's of a class. I said add, okay, what is my add type? Add type, it's saying it's like an object, okay. It's a class type, okay. So everything is object in Python, even function is also object, okay. So if I see here, add, right? This add is a function, but it is nothing but an object of a class function. There is a function class and it is an object of that class function. Then if everything is an object, I can assign it to variable, right? So very simple. I can say I'll assign this add function to a variable, and I'll call sum of 10 comma 20, and I can say print. So it is nothing but you don't define the function sum, but this is nothing but a variable sum. So functions can be assigned to variables. Few things like in C, it is like function pointers. Okay, the same concept here. You can assign a function to a variable. So I did assign function to variable. So if you assign function to variable, you can do so many magics. Okay, so it's nothing but I assigned sum to a variable and I did sum of 10 comma 20. Okay, so now let me do something like some more changes. If I assign to a variable, I'll now I have a b c. Okay, I had a function called add more, something like that. So I have def add a comma b, return a plus b. So let me invoke this print add more. I'm passing add function, and also I'm passing b as 10 and c as 20, and I'll call okay, I'll call it an add more. Pay light attention to this. What I'm passing is I'm passing this function as an argument. So I'm passing this a contains an add function, and b comma c is 10 comma 20. So it is nothing but it will call add function with a plus b. So it is nothing but adding 10 comma 20. So which is nothing but 10 plus 20 is 30. So passing, what I'm doing here, I'm passing function as an argument. So I'm passing this add function, nothing but add function. I'm passing this as an argument. Then I pass this as an argument. Then I can say 10 comma 20. I can invoke that function. So functions can be passed as arguments as well. Function assign function to a variable. Function can be passed as arguments to other functions. Okay, so you guys got this very confusing example. If you pay attention to this simple syntax, right, the several data science libraries uses this concept very well. So the libraries take functions as an argument. So you can define your new function and pass that as an argument to it, and they can start using that function. So why we pass function as an argument is like, so open for extension and closed for change design principle. I don't want to confuse you with this syntax or this statement. You can follow. This is very popular object-oriented design principle. And when you define a library, you should allow for extension. Okay, they can do something more about it, but they shouldn't change it. You shouldn't allow them to change it. So for example, if you have a sorting library, it should sort employee object, it should sort numbers, it should sort anything. So it will allow you to do an extension to it, but not allow you to change the sorting library or something like that. Okay, sorting philosophy inside it. That's the reason. One thing you need to understand, you can pass functions as arguments. I'm passing add function as an argument to add more, and you can do more about it. So why I covered this as like, because lambda functions are nothing but functions. So you now let me change this a little bit to a lambda. So what I'm doing is, now what I'm saying is like, lambda lambda a comma b, and I am saying a plus b, or I don't confuse you with this simple I'll just now let me create one lambda function which does addition of two numbers a comma b. These are arguments, and I say a plus b. This is simply a lambda function. Okay, remember the syntax: lambda, arguments, and expression. It should be only one expression. You cannot have multiple expressions. So like you cannot have a plus b, and you can say a minus b comma a by b. You cannot have like this. Okay, it can take only one expression. Comma separates the expression, right? You can have only one expression, a plus b. Okay, so this is a add lambda function. It is nothing but I removed the def keyword, I removed the open and closing parenthesis, and removed that return. This is nothing but add lambda function. If someone wants to invoke this very well, I'll assign this to variable add, and I can say add of 10 comma 20, and I'll just add it as a print. Okay, so this simple it is. So lambda, a function can be assigned to a variable, right? I just assigned to a variable add, and I'm just calling that. So a plus b expression gets evaluated and it returns, so it prints. So if you want to further simplify, if you want to, I can also do like this. Okay, I can simply say print, and this is my lambda, this is my anonymous function, and I'm invoking with argument 10 comma 20, and this is how you can do this. Okay, so if I run this piece of a code, it is nothing but 10 plus 20, that is. So if you see in the first time, you will get scared with the syntax, but it is nothing, which really a stupid anonymous function. So you have a arguments return, and you are invoking that anonymous function. This anonymous function can be assigned to a variable like x, like z, or something like that. You can do this also. You can assign it to a variable, and you can call it, and you can do anything. Once you have that variable, you can, this is also very valid. Okay, if I have print, you will understand. You can do various way of doing it. Okay, you can invoke that function like this on that variable. So once you have it as a variable, you can pass it to the other function. So you can pass lambda function as another function as well. So now you understood the lambdas, right? So I'll show you one real very good lambda functions as arguments. So if you can see here the same example with what I had. I created one lambda function, and I'm passing all the arguments, and you can do anything on top of it. Okay, so that's about lambdas. So simple way to remember is lambdas are anonymous functions which will take only one expression. Okay, so what I mean by that, I'll explain you one example with this one expression. You will understand. Lambda a comma b, I want to do a plus b, and I want to do a minus b also in a single step. Okay, and I try to do this, and I'm trying to invoke 10 comma 20. So if I try to do it, it will complain you. Okay, it cannot do that. Okay, so what it says is like, so what it says is, okay, it can have only one expression. So but if you want to, you can do this as a tuple. You can return this as tuple, the entire, this is a one expression. This is perfectly equal, so it will be like 10. If I have print it, you guys can see, understand well better. Okay, print if I'm returning a tuple instead of a one variable. I'm just doing 30 and 20. So do remember, this is one expression, not multiple expressions. Tuples will help you in this case. Tuple is a immutable data type in Python. You can do that like this. So any questions on lambdas? Okay. Now let me show you one real world use case with lambda, which I wrote here. So there is a predefined sorted library. Okay, sorted is a way to sort a values. But my sort function needs to be on the length. So I'm passing 3 strings, okay? So based upon their length, I need to sort, but not based upon their ASCII characters, okay? A comes first, B comes second, C comes D. Okay, I don't want to sort an ASCII character. I want to sort on their length. So you want to change the behavior of the sort function. So what they say is you pass the sort function behavior, okay, as a key. How should the key needs to be behaved? I said length is important for me for that key. Okay, so then you can do this. This is a lambda function, takes an argument, and for me is like length is the first important thing. So if you see, then sorting by length, it yields like this. So first, two, three. If I didn't sort by length, okay, so if you, the first sort is normal sort, which is like based upon their ASCII sort. But the second sort is based on length sort. So sorted by length. I'm passing the lambda function here. So this is how, if you want to change the behavior of a predefined libraries, you can pass lambda functions. Now, lambda functions are very popular in Java and also in Python. So they are nothing but anonymous functions, which will have only one expression. Okay, and they can be passed as an argument, and they can be treated as everything. Function is an object, right? If it is an object, you can assign a variable to it, and you can invoke it, and everything you can do that. That's what about the lambda functions. Okay, so now we covered functions. Let me go into the another topic, very important topic in Python, is like exceptions. So we have another 10 minutes. I'm going to cover exceptions. Learning them to the strong, if you learn them very well, right? So learning the other libraries, when you're going to a higher level in Python, when you are going to higher level in Python, okay, uh, whether you are writing an API, whether you are learning a data science, it doesn't matter. When you learn the basics very well, then it's like a syntactic sugar. Okay, people write a very complex lambda expression where you get scared. Okay, what is this? I am not able to understand. Okay, but if you understand the basics very well, you can decipher it very easily. That's the reason I'm stressing more on the basic concepts. Well, okay, what is a function? Function with arguments, keyword arguments, positional arguments, returns. Function can be assigned to a variable. Function, anonymous function. Okay, so that's about all about the functions. Now let us pay attention to exceptions. What is an exception? Okay, unexpected behavior. Unexpected behavior. If you have an unexpected behavior in program, you need to handle that. So you need to handle it. So if you ask someone to pass an integer, they are passing a string. Your program shouldn't freak out and break. Okay, it should say don't pass string. So unexpected behaviors, you need to handle them very well, so that your application will be very robust. So exceptions will help you to handle unexpected behavior in your program. So in Python, exceptions or errors is same, unlike Java. Okay, don't go into that place, because if you are not a Java guys, is same, and they are objects of exception class. That's it. You need to understand one simple statement. Exception or error is an object of exception class. So if some unexpected behavior came in your program, it's nothing but an object of an exception class. When an exception arises, exception occurs. If you don't handle it, application will terminate with trace. So it gives you trace where that exception occurred and it terminates. It won't further run the program. So, but your program needs to be robust, right? If someone gives you a wrong input or something, it shouldn't terminate. It should handle gracefully and say that, okay, I cannot run. So that's what an exception typically mean. Okay, exception is an unexpected behavior in the program, okay, where the program terminates and returns a trace, okay, where that program terminate, where I stopped executing and that trace. So let me give you with a little bit of examples, okay, like yeah, I'll write with one simple code. You will understand the exceptions well. So you guys clone my GitHub repository, which is publicly available. Every time I'm sharing you, okay, you can clone that. And so let me do one. Let me try to say you with one example. Okay. Now I have a function called called change, something like that. I have a function called change or convert. I'll say convert is more easy. So which will try to convert a int to string. So I'll say return int. So if someone pass me a string, I'll just convert it. So let me do an example. Print convert of, I try to convert 10. Okay. So if I run to convert function, okay, it is converted. Int is a predefined function which takes strings and convert. So if I now try to do a convert of something like ABC. Now I'm trying to convert a ABC string into integer. So, and the program terminated. It says that I cannot convert ABC to an integer. So this is an unexpected behavior and your program terminated. So with the stack trace, with a trace where the problem occurred. The program occurred at a line number 2. It clearly says the problem occurred at a line number 2. This is not you expected. This is not the way you write an function, right? It needs to be durable. Now let us try to handle these exceptions. So what happens is, let me try. You can do with try. So int of a return. Okay. Except it accepts something like what we are getting, value error. It expecting a value error. If something gives a value error, I'll say return. I'll say I don't do anything, but I'll say print. I'll just print I am unable to convert. I'll just spring unable to convert and I'll return gracefully. Sorry. I just enhanced my code with, so simple thing is a try and accept block. You can achieve exception handling. Exception handling can be achieved with these simple things. Try and accept. Okay. So these two blocks you can achieve exception handling. I'm saying try return integer of a, I try to convert, and which gets a value error. The except immediately the exception arises here and it comes here and I'm catching the exception here. And I'll say I'm unable to do anything. If you run this program, if you say unable to convert, it clearly says unable to convert and it is returning none, it's not returning anything. So this is nice way to handle exceptions, right? So if you expect some piece of a code is going to generate an exception, you put it in try block. In exception block, you try to do the the remediation technique. Okay, what should be done if that exception comes? What should I say? Should I say back to the user nicely, or should I do something? You can do with this simple way of except block. Okay, so now let us try to do something more here. I try to pass now a list, okay, instead of a string. Now what my function program behaves, once again it says, so it's not throwing a value error. If I try to pass, if I try to now now if I try to convert a list to a integer, it is saying type error, it is not saying value error. So now what I'll do, okay, I'm not expecting a value error. I just copy paste and say I'm expecting a type error. Okay, so I expect this int returns two types, okay, value error and type error. I have two except blocks. If I run here, once again it turns out empty root. So you can have an hierarchy of errors that you are expecting to get. This is a one way to handle a multiple exceptions that comes out of a program. Okay, your integer throws value error and type error. So you can do this, or the simple other way to do this is like, instead of I'll why to have a two except blocks, I can combine these two except blocks with a simple tuple like value error comma type error. I expect these both, and this is a very simple way, easy to. So I expect either type error comes or other value error comes. So if I try to change little bit this code, so if I run, okay, first one will generate a type error because it is trying to convert a list to a integer, which generates a type error and unable to convert it, say. And the second thing is like, I'm trying to convert a string to an integer, which gives an value error. So you can handle multiple exceptions in two ways, okay? So you can have multiple exception, except I should say, except blocks, or using tuples. You can combine them as a tuple and you can achieve it. Okay. So you can assign a variable also. So as you can say something as ex, something like that. You can assign it to a variable and you can see what type it is. So if you say ex, so it's nothing but the exception object that comes, right? You are assigning it to a variable to ex. Okay, you can see the first one is like, it gives you more information. Okay, it says it's not a list. Okay, it says it's invalid literal. Okay, so an exception can be assigned to a variable. So what I did is, an exception object can be assigned to variable using keyword as. So you can use a keyword as and you can assign it to a variable. So now I assign it to a variable ex and I'm using that. So now when an exception comes, right, the below the execution terminates here itself. So I'm not executed. So you need to understand this also. So if the exception occurs here and immediately jumps back to this block. So the statements below that exception are not going to be executed. So this is what happens now. Now I'm not executed. This statement never comes because here I have a return. If I want to simplify further this, I can have it as value, and I can finally change a little bit about this return value. Okay, So, and I'll have print convert of something like 10. So first conversion is successful, and it says this is successful and this get executed, and except block is ignored, except block is ignored, and you are returning a value. Okay, so when an exception arises, it jumps and it goes here. So now let us learn about global exception handler. So sometimes we use libraries and we don't know what exceptions they have. Global exception handler. So if there's some global exceptions, you don't know what a library, you never know what exceptions it throws. So you're uncomfortable with that. Then you know, right, in Python, everything is like an exception class. So every exception is a subtype of an exception class. You can simply say, I don't know anything. I just say exception. This is good enough for you. It will handle all the exceptions. So if I run here, so it is handling all the exceptions. You see here, you don't need not to repair it. It's a type error, it's a value error, or XYZ. Okay. So global exception handler is also present in Python, which is nothing but an exception class. So that's about global exception handler. So when you write a library, people won't use global exception handler more, because based upon situations, they respond to the user saying that, okay, you are not, you are supposed to send as a string, you are supposed to send as an integer or something like that. Okay, global exception handlers are less likely to be used, but they are very helpful. So that's about global exception handler. Okay, one more important thing which you can understand. Okay, you know, right, return and pass are same. So you just pass. This is more elegant syntax. It pass that block and it will run. So okay, I got the point here. What happens is, if you say, this is more easier because the value. So pass is like it passes that block and it comes to here return, and it shows this. So pass is like executes, comes out of that block, this block, it comes out of that block and goes to the next block. Another another important thing in exceptions is like re-rise an exception. An exception comes, you want to rise one more value. So for example, there is another keyword called rise, like, and you can pass saying that I'm getting a value error or something like that. Okay, so this is also very important thing. Okay, if you want to re-rise exception, you want to rethrow an exception, you can use a rise keyword. Okay, so the rise keyword is, rise is used to throw exception. Okay, so you feel that, okay, I cannot handle these many errors. After some time you want to give up. Okay, you handled so many times, 10 times people passed the wrong value, but that 11th time also is passing the wrong value. I want to terminate my program. I don't want to infinitely educate the customer. Some hypothetical scenario you want to say, you can use rise as a keyword and the program gets terminated. So if you want to understand exceptions in Python, remember these things very well. Exceptions or errors is same. They are objects of exception class. You can do exception handling using try and except keywords. Okay, and an exception object can be assigned to variable. So that's all about exceptions. So anyone have questions on exceptions?
No, Balaji, we are good, I think.
Okay, so this entire section what I covered, exceptions and functions. Probably execution model I'll revisit, because you guys, and once execution model is like, they in Java, Python has garbage collection. Okay, scope and execution model and garbage collection needs to be treated together. Then you will understand how Python works. Okay, so when you say about execution model, you need to understand scripts, modules, libraries, garbage collection, and scope. If you understand these five things well, then you understood the Python execution model very well. Okay. Why do we need to learn in such a depth manner? Because if you understand them in depth, any runtime problems you can easily debug. You can be like a strong Python programmer and then a mediocre Python programmer. Okay. So that's the essence of my sessions. Okay, I want my students to be a strong Python programmers, and they can clear any tough or toughest Python interviews. And they excel in learning, whether they do a API application programming, whether they infrastructure system programming, whether they do a data science on Python. These basics are very common. If you know them, it's very easy. Else, it will be like, okay, it will be like, okay, I learned data science in Python, but it's not getting me well. Okay, every time I get scared if I see different syntax or something like that. Okay, so that these basic scores will help you to overcome that fear, and that's the main motto of running this session. If you'd be overrun by 15 minutes, but thank you for the team for joining, and I'm going to share the recording of it. Have a nice day ahead. Thank you.
Thank you.